Hi guys, today we're going over the Density of Common Materials lab. This is kind of a continuation of the last lab we did on volume, so we will actually be using some of the volumes that we recorded in the last lab. Part 1 says, density is one of the blank properties of matter that helps us to identify what a particular substance is. It is a measure of the amount of matter in a specific volume of a substance, okay? The blank you're looking for is physical. If you want to get specific, you can say intensive because it doesn't matter how much water you have. You can have 1 gram or 10 grams, but the density of water is always going to be the same no matter what volume you have. So physical or intensive can fill in your first blank. For number 2, remember the almighty equation. I love density. With your heart, remember, once you split it, equals mass over volume. I love density. Density equals mass divided by volume. Your mass should be in grams, and your volume can be in either milliliters or centimeters cubed. By that, I mean 1 milliliter, which is a measurement of volume, equals 1 centimeter cubed. Okay, we don't cube a milliliter because that's already a dimension of volume. That is a length times height times width. You don't cube a milliliter, but if you're using a centimeter cubed, you're multiplying a length times a length times a length, which is centimeters cubed, okay, because you're multiplying 3 lengths of centimeters together. You can interchange a milliliter and a centimeter cubed, no problem. They mean the same exact thing. Part 3, the fact that density is described by a combination of fundamental and derived quantities makes density itself a derived quantity. Remember, density is mass divided by volume. Mass in grams, that is a fundamental unit. Volume in milliliters or centimeters cubed is also a fundamental unit. So if you divide a fundamental unit by a fundamental unit, that makes a derived unit for density. For most solids and liquids, density is written in the units of gram per centimeter cubed, grams being your mass and then your centimeter cubed being your volume. For gases, density is sometimes written in units of gas per liter. You might ask why that is, okay? Just remember that gases are extremely light, so you need a lot of gas in order to get a decent measurement of gas. So gases, you're going to need a full liter instead of just a teeny tiny milliliter to get an accurate mass of that gas. So part 5 is when we actually transition into doing our density lab today. In part 5, it says, in your volume lab, you measured the volume of 4 different objects. So we have object 1, a wood block, object 2, a plastic cylinder, object 3, a rock, and object 4, a metal cylinder. You already have the volumes of those, so you have half of the density equation already done. Today, we need to figure the mass of those and divide mass by volume to get our density units. So for the wood block, our first item, you should have a volume of 113 centimeters cubed. Let's go ahead and get the mass of this block. And the mass of the block is 74.3 grams. So again, density is mass divided by volume. So you take the mass of 74.3 grams, divide by the volume of 113 grams, and you get a density of 0.658 grams per centimeter cubed. Notice that I had the same number of sig figs in my density that I used in my mass and volume. Also notice that density was not just a number, okay? We have mass in grams per centimeter cubed. Remember the NNN rule, no naked numbers. All numbers need units. For object 2, our plastic rod, which we're using the brown one in this video, okay? The volume you should already have is 10.7 milliliters. Let's go ahead and find the mass of that. And you write it in your data table here. And you get a mass of 14.1 grams for this brown cylinder. Again, you take your mass of 14.1 grams, you divide by the volume of this, which we said was 10.7 milliliters, which is the same as 10.7 centimeters cubed. So you take your 14.1 and you divide it by your 10.7, 3 sig figs in each of those, right? You should get 1.32 grams per centimeter cubed as the density of your plastic rod. Next up is our metal cylinder, so let's go ahead and get the mass of that. It shows 55.8 grams as the mass of this metal cylinder. The volume we used in the last video was 20.1 milliliters. So again, we're taking our mass, which is 55.8 grams, you're dividing by the volume, 20.1 milliliters or centimeters cubed, either one, and you get 2.78 grams per centimeter cubed. Our last object is this rock. In the last lab, the volume was 42.0 milliliters. So we're going to go ahead and get the mass of this rock, which is 103.2 grams. So again, we're taking our mass, 103.2 grams, we're dividing by our volume, which is 42 milliliters or 42 centimeters cubed, and you should get 2.46 grams per centimeter cubed. So now we have found the density of the wood block, the plastic rod, the metal cylinder, and this rock. Now, Mr. Miller provided us a list of the actual densities of the plastic rods, okay? We used the dark brown one. So the point of this is, let's see how close you got to finding the actual density. When we need to figure out how close we are to an accepted measurement, we use percent error, okay? Percent error, you take your experimental value minus the accepted value, divide by the accepted value, times 100. In our case, we got 1.32 grams as our experimental value. Luckily, the accepted value is also 1.32 grams per centimeter cubed. So if you take 1.32 grams per centimeter cubed and subtract 1.32 grams per centimeter cubed, you get 0. 0 divided by the actual value of density for the plastic rod, okay, is 1.32 grams per centimeter cubed. 0 divided by any number is 0. Times 100 will give you 0% error, meaning we found the density of this rod perfectly. The last part of the density of common materials lab that we're covering is you are to find the density of water. You know that density equals mass over volume, so in order to find the density of water, you need to find a mass of water over a volume of water. Here's what I would do. I would take a graduated cylinder and get the mass of that cylinder as it's empty. Then I would fill up the cylinder with a known amount of water. So in this case, I filled it full of 50 milliliters of water. Then you take the mass of that. Then you subtract the full graduated cylinder with a volume of water in it, and then you subtract the empty graduated cylinder mass alone. That should leave you with the mass of the water alone. You know that there's 50 milliliters of water in here, so if you take the mass of just the water and divide it by our known volume of 50 milliliters, you should get a density of water. If you did this correctly, water has a density of 1 gram per centimeter cubed, and all densities are based off of knowing that water is 1 gram per centimeter cubed. I hope this video helps. Thanks for watching.